So now we're going to poison the data set. Now, this is the MNIST data set, which we've used before. It's going to have these images. Some are 5 and some are 9, and they're labeled with 5 and 9. Now, what we did before was an evasion attack. By adding a few random pixels, sort of like snow on here, we were able to confuse it and make it mislabel a 5 as a 9 and a 9 as a 5. And that was evasion, where the model is trained and you make an image that will confuse the model. Now, this is poisoning. We're going to modify the images that are used to train the model. And you can carefully, now you can, of course, one thing I did before an earlier project we didn't even go through here is I would just strip some of the labels, label some of them wrong. That turns out to be a relatively ineffective attack, and it takes a lot of bad labels to confuse the model. You can do better once you know the model. Like I said, you can look at the model and find out which pixels have the most weight. And you can decide what pixels being wrong would confuse the model the most. And the library here will do that. SecML is the security machine learning Python library that has this attack built in to perform poisoning. This is poisoning. Change these images in such a way as to do the most harm to the model when training. And so if you do that, you make a single poisoned image. This is the poisoned image. You add one image, which is a 5 with a couple of pixels changed. And that single image causes the accuracy to fall from 93% to 79%. This is very effective. Just a few malicious images can completely confuse the model. And now you can try poisoning 5 images. And you see these 5 images are now have extra little pixels added to them, which don't do anything to humans, but have been carefully chosen to maximally harm the model. And now the accuracy after the attack is down to almost chance, 57%, making a binary choice. So it's pretty amazing stuff. And you can, there's different poisoning images. There's some parameters. And here's another group of digits to poison. We do 1s and 0s instead of 1s and 5. You can see these little snowy dots out here don't seem like they would do anything, but they do great harm to the training model. And this is something to understand. Little changes you won't notice could be ruining the model in both the training stage and when using it to evaluate images. And this is a thing to worry about. I mean, how do you know that nobody has done this to some of those images you scraped off some random image board on the internet to use? And this is why the more modern technique that many people are saying is, I'm not going to use random garbage from the internet. I'm going to train my model on data that I collect from my company, my customers, something like that. It's paying attention to where your data comes from and what your samples you're using are like is going to make this all much safer. Anyway, I'm going to stop that recording.